Hi everybody, welcome to video notes for objective 4.1. We're going to name and write the formulas for ionic compounds and understand the rules for them. So we have to tell the difference between elements, compounds, and ions. Elements only have one type of atom. Compounds have two or more types of atoms bonded together to form an overall neutral substance. And ions are atoms or groups of atoms that have a charge. So please write this in an example of each in your notes. So we have H2. That is an element because it's got one type of atom. Fe, element, one type of atom. FeO2, compound because it's got two different types of atoms. CO3 -2 is an ion because it has charge. CO2, compound because it's two or more types of atoms bonded and it's neutral. CaCO3, compound. Fe plus 3 is an ion, and N2 is an element. Make sure you can identify those yourselves. Polyatomic ion is a new type of substance for us. It's an ion, has charge, but there's more than one atom bonded together to make the polyatomic ion, and overall there's either extra electrons or somewhere along the way they lost electrons. So CO3 with the -2 is an ion because it has a charge, but it's polyatomic because it's more than one atom. Here's a picture of a dot structure for CO2. Notice the covalent bonds holding those atoms together, but because there's extra electrons, there's two negative charges on the overall substance. OH minus or -1 looks like this. So there's a covalent bond holding the hydrogen and oxygen together, but overall there's an extra electron making it a poly, more than one atom, ion. CO2, that's carbon dioxide. It is not an ion because there's no charge overall, and it's a covalent compound. NO3 -2 is called nitrate, and it's an ion. It has an extra 2 electrons, but it's nitrogen and oxygen covalently bonded. So it's a group of atoms working together, but they have extra electrons. And then zinc, yes, it's an ion because it has charge, but it's not polyatomic, it's monatomic. Monatomic ion. Monatomic ion. Because it's only got one atom with a charge. So you're going to have to know a lot of polyatomic ions. You got a sheet like this in the mail. It lists the names, and if you don't have it in the mail, at least you have it on these slides. So it lists the names of many polyatomic ions, their chemical formula, so how the atoms are bonded together, the overall charge, and then if you write the ion with the charge, you would put it like that. So ammonium is NH4 +1. Cyanide is Cn -1. Notice the capitals and lowercase is really important. Chlorite is ClO2 -1. So it's chlorine and 2 oxygen covalently bonded with an extra electron. Here are some more that you have to know. You may have heard of some of these like hydroxide or nitrate. So you have these, you get to look at these, you get to use them, you got to know how. Ionic compounds then are when a positive and a negative ion make a compound. So there's going to be the positive ion first, so it's going to start with a metal or the polyatomic ion called ammonium. Then it's going to end with a nonmetal or a polyatomic anion with the negative charge, negative, and it starts with the positive. Okay, so NaCl is a metal and a nonmetal, so this is an ionic compound. KNO3, we have a metal, and you don't recognize it yet, but you will start to. This is a polyatomic ion, so this is an ionic compound. S is sulfur, and that's a non-metal. O is oxygen, which is another non-metal, and then you say to yourself, self, remember covalent, that is a covalent compound. All right, NH4, that's all non-metals. SO3, that's all non-metals. But look, this is ammonium, and that is sulfite. And hopefully you'll start to recognize that, but this is an ionic compound made of two different kinds of polyatomic ions. Here we have a non-metal and another non-metal. Son of a gun, that's a covalent compound. Here we have a non-metal and a non-metal, but look, it's got a -2 charge, so this is a polyatomic ion. So the new thing we're learning right here is an ionic compound has a positive and negative part. Could be a metal and a non-metal, could be a positive polyatomic ion and a negative polyatomic ion, could be a metal and a negative polyatomic ion. So ionic compounds, again, metal or ammonium and a nonmetal. The positives and negatives must balance, kind of like that elephant on the big beach ball. Okay, so sodium sulfide. Let's see how to write the formulas. So here's some rules for writing formulas for ionic compounds. Give yourself a chance to read through these, and then we're going to use them. Okay, so you got to recognize that it's an ionic compound. You got to use a periodic table or an ion sheet for charges. If you see a Roman numeral, you know the charge. Make sure you have enough ions to make the positive and the negative equal 0. And then keep things together with parentheses if you need to. And no charges in the final answer. Okay, periodic table. How do we use that to find charges? Some metals always have the same charge. Group 1A plus 1, 2A plus 2, aluminum plus 3, zinc plus 2, silver plus 1. Okay, so it's plus 1, plus 2, plus 3, plus 2, plus 1. Write all over your periodic table. Find a periodic table, write it now. And it's because they always lose the same number of electrons. Lose the same number of electrons. Okay. Some nonmetals always have the same ion charges. What? Okay, what are those? So group 7A, negative 1. 6A, negative 2. 5A, nonmetals, negative 3. Okay, so negative 1, negative 2, negative 3. This might seem familiar because it should be. We talked about this. Why? They always gain the same number of electrons. Same number of electrons. All right, so I call them always charges. I sometimes say always metals. Group 1, group 2, aluminum, zinc, silver, always plus 1, plus 2, 3, 2, 1. Always nonmetals, negative 1, negative 2, negative 3 on those groups. Okay. Roman metals then are the ones that don't always form the same charge. Now they're metals, so it's always going to be positive, always positive. So they maybe lose 2, maybe lose 3, maybe lose 4 electrons. And so we use a Roman numeral in the name of the compound to tell you how many electrons were lost. So 1 electron lost is a Roman numeral 1. 2 is 2. Plus 3. Plus 4. Plus 5. 6, 7, and 8. Since these are metals, these will always be positive charges. So here's a name, iron 3 chloride. That means that the iron has a plus 3 charge. So let's practice using those rules. So calcium bromide. I think one of the great ways to do it is to find calcium on the periodic table. It's a plus 2. Write a plus 2. Find bromide. But wait, there's no bromide on the periodic table. There's bromine. And then the ending is IDE. So here's bromine. It's a negative 1. So we have a calcium with a plus 2 and a bromide with a negative 1. So we need 2 bromides to make it equal 0. There we go. Okay. Aluminum oxide. Aluminum plus 3. Why? Plus 3. You'll always get a periodic table. You just got to know the charge. Oxide comes from oxygen. It's negative 2 column. All right. So let's try to make this 0. So we got 3. 2. All right, now it's negative 4. Now it's positive 6. Now it's negative 6. So we need 3 of the aluminum. So aluminum 3 times. Oxide, I'm sorry, aluminum, there's only 2. Come on, can you count? Yes, I can. All right, there we go. Aluminum oxide. Sodium acetate. Sodium plus 1. Acetate, what? I've never heard of acetate. I can't find it anywhere in the periodic table, but look, it's here. C2H3O2. C2H3O2, negative 1. All right. Oh, it already works out as a plus 1 minus 1. So we just have to write the symbol of the first thing, the symbol of the second thing. Sodium acetate. Magnesium sulfate. So magnesium plus 2. Sulfate. I can't find it on the periodic table. But look, here it is. Sulfate. SO4 negative 2. You don't have to memorize them, but you would if we were not in remotes or hybrid. We'd have to memorize them. So you'll use them enough that you'll probably memorize them, but you get to have that. Okay, aluminum is a plus 3 still. Sulfite, notice it's ite. SO3, -2. All right, so we got a -2. That's another -2, +6, -6. So we need 2 of the aluminums, Al2, and we need 3 of the sulfites. So I have to write SO3 because that's its identity. Put that in parentheses and put a 3 outside to show 3 of those whole things. Ammonium carbonate. Ammonium you will not find on the periodic table, no however much you look. It's right there. Ammonium is +1. Carbonate, CO3, -2. It's right here. All right. So look, a +1 and a -2, we need another +1. So we need 2 of those. So I write NH4, and then I put it in parentheses, and then I say I need 2 of those whole things for every 1 carbonate. So I don't need parentheses on the carbonate. I do have to keep it together. Potassium nitride. All right, potassium is +1, because here it is. Potassium +1. Nitride, ide, I'm looking here, I don't see very many ides, those are mostly aids. That's because it's coming from the periodic table. It is a -3 charge. So I need 3 of these, 3 Ks, and 1 N. All right, copper 2 oxide. All right, copper, Cu. Wait a second, it's in the area that's not always the same. What the? That's what this is for, +2. +2. All right, oxide is here. It's a -2. So we just need a CuO for that one. All right, get rid of that. Copper 1 oxide. Oh, here's copper again. Cu. Hey, it's not an always. That's why there's a 1 +1. Oxide is an always, but it's always -2. So I need 2 of those to get a +2 total. 1 of those to get a -2 total. Lead 4 carbonate. Here's lead. Wait, it's not an always. So, oh, fancy that. There's a +4. So we have Pb for lead +4. Carbonate. Carbonate. Ooh, there it is again. CO3 -2. Wait, that doesn't equal 0. I need another one of those. All right, so I would write Pb 1 time. Put parentheses, right, CO3, because that's the carbonate ion. And I need 2 of those. Formula writing, woohoo! Okay, next. Oh, just a little Roman numeral fun. Definitely pause and read that. Okay, what if you have to write the name of an ionic compound? Well, recognize that's ionic. Write the first thing first, cation, positive, and the anion second. Look for the Roman metals and put in the parentheses. Put the Roman numeral in as the charge. Okay. Writing the names, K2O. Well, K is potassium. Write it down. Potassium. O is oxygen, but you change it to IDE, oxide. Then we check, is potassium always? It's always a 1, so we don't need a Roman numeral. Sodium. Na is sodium. N, nitride. So you change the ending to IDE if it's coming off the periodic table. Do we need a Roman numeral? No, sodium's always a +1. Potassium. CN, that's 2 of them. That's a U. Cyanide. CN, cyanide. Cyanide. Yeah, that stuff, look at this. So don't eat it. Potassium cyanide. BaOH. Ba is here. It's a barium. All right. And then OH in parentheses, that must be a polyatomic ion. Can I find it? Can I find it? Can I find hydroxide? All right. So what does that mean? Do we need a Roman numeral? No, because barium's always a +2. Right there. AlCl3. So here's aluminum. Aluminum's an always +3, so we're good. Aluminum, don't need a Roman numeral. And Cl comes from this, and it's chloride. All right, so the second word is IDE if it's coming off the periodic table from these nonmetals. And then the second word is this word here if it's a polyatomic. Okay, Na is sodium. And C2O4, C2O, oxalate, C2O4, oxalate. All right, home stretch, Fe is iron. Right about here. Wait, that doesn't always have the same charge. Son of a gun. All right, so first write down the name of the second part, carbonate, right there, carbonate. Now let's figure out the charge. So there's 2 Fe, so I'm going to write it twice. Why? Because there's 2 of them. there's 3 carbonates. I'm going to write it 3 times. You're like, Harbin, I can't even see that. Well, it's there. It's there 3 times. So then I say, all right, this had to equal 0, and I know carbonate is a -2. -2, -2, -2 is -6. That means this has to be +6, so each one of these is a 3. Fun times. We got to put a Roman numeral of 3. CuCl2, copper. Copper, and Cl is chloride. Then I say, wait a second. Copper is right here. It's not in always, so I need a Roman numeral. So I do what I did before. Cu, 2 Cl's. We know Cl is -1 because this column's always -1 over there. And then there's 2 Cl, so this must be a +2. So we put a +2. All right, this is iron oxide. And then iron again, son of a gun, Fe, Fe, O. That sounds like someone would say at Christmas, but oxide's always a -2, so these must each be +3s. Iron, 3, oxide, PbSO4, Pb is lead. Lead is not in always, and then SO4, sulfate, SO4, sulfate. All right, and this is, let's see, this is a -2. Oh, write them down, write them down. Wait, I don't have room. SO4, SO4, there's 2 of them. It's -2 each time, it's capital, and there's only 1 lead, so lead must be a +4. Lead, IV, sulfate. Okay, all right. Acids, I'm just gonna put these notes up here. You can read them. Acids start with hydrogen. Here's the systematic way to write the names of acids, and it all depends on what anion is with hydrogen. And so here's some formulas. This is hydrosulfuric acid. 2 words. This is sulfuric acid. And this one is sulfurous acid. See if you can figure out why using the slide before and after this. Okay, these are names. You see the word acid, you know it starts with an H+. Oh, H+. And then ic acid in hydro came from IDE, so that's N. So it's N -3, H3N. This one is HNO3, and this one's HNO2. Figure that out. Here's the review slide to review. And here's the objectives again. Okay, hope you enjoyed.